quickly here. Cos. So what's somebody tell me what cos of A minus B is, please?
Yeah.
Okay, great. Can I get somebody to sub in some numbers for me, please? Katie, be brave. You can do it. Okay, great. What is cos pi by 2? 0. I'm going to spend... Quantità demonstratum. All right, let's move on to graphing here quickly, just so you can remember the fundamentals of graphing here for this. And then we're going to do graphing and solving trig equations, and I'm going to stop and hopefully try for calculus. I might not, okay, because this is sort of heavy here today. So here we go. Graph, sine, cos. Harry actually lied to me in graphing today.
Oh no.
Yeah, I don't have any either.
Can I have my test back?
No.
That's my only graph.
Hey, you want some graphic?
Yeah.
I actually have some. So those are-
You actually do?
I actually do.
Can I have?
Yeah. Would you like some graphic?
Quarter points are how that. Quarter points. Okay, so this one's going to go quickly. Let's just say up. All right. I'm going to very, very quickly show you where the graphs of sine and cos come from the unit circle. Then I do one more complicated graph with transformations. All right. In calculus, we are not ever going to graph sine and cos, but I will make you graph something like x squared sine of 3x plus 4 plus 2y. You know, it's like messy things like that. I'll make you graph. Okay. So these fundamental ones, I just want to get to the idea of those periodic graphs and all that stuff. Where this all comes from is the circle, okay, that I keep harping about, all right? The circle of home. That's our theme song, but that's okay. All right, so there you go. There's that. So what you should also do, though, is you should probably have a unit circle handy. So I'm just going to draw a quick unit circle on here, because this is going to show us where the main idea of this graph comes from. The period of the graph is going to be 2 pi, because that's what the circumference of the circle is, right? So this is going to be the point 1 comma 0. This is 0 comma 1. This is negative 1 comma 0. This is 0 comma negative 1. Okay, right? So you should sort of have that. You have that in your notes already here, but this will be sort of necessary. I'm going to put sine and cos on a very small graph together. Okay, so it's going to be, and then I'm going to do the transformation. If you can't see that, because you're over there, I'll draw on the side of the board if you can't see. Okay. So what I just got. I don't really know. It must be different. It must be different. So this should be in the notes already, so it'll be good.
What is it?
So if you want to use this 3D page saver, and it's trying to get 3D.
I can't use that.
Okay, here we go. So let's get a quick graph. Here we go. So I'm going to quickly graph sine theta and cosine theta. If you have graph paper, this might be good to do on. We will be doing one day of graphing in this unit. Basically, the way all of the calculus units work. And you know what's sort of sad? Is that we're in our second last unit. So we have two units left. 22nd, 28th will be done by June 5th or June 6th. So we'll probably get a week of study time before our exam, which will be sort of nice. Okay, yeah, you just okay. That's it out loud. I don't need to say that out loud. Okay. All right, so here's my graph here. This graph is going, what's the max and the min of the periodic graph? 1 and negative 1. Okay, so there's y. And 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to do a revolution and a half here. I just want to get the idea of the shape just so that it sticks back to your brain there. Okay. So I counted just over to 3 pi. If you want to go to 4 pi and continue, that's fine. If you want to do some negatives, like Harry's doing, that works too. Okay, negatives. If you don't do negatives, that's fine as well. Either one is okay. So I'm just going from 1 to negative 1. All right. We'll do our transformations in a bit and show you how they get to be wild and wacky and bigger than that. Okay. Okay. So this is coming back. So I would like you to use the unit circle. And tell me what cosine of 0 equals, please. Oh, it's way too much for 5s. Now, I'm just going to yell at everyone for a second. Do you remember what Reed Snyder, when he came in here 2 weeks ago? No, everyone just tuned him out. But if you notice what he said, he goes, there are no calculators in calculus. And Mr. Saladin should spend a lot more time on the unit circle and trig because they need to know it better. That's what he goes. Okay, I said, is there anything I could do better? He goes, spend more time on trig. Okay, because this stuff here, when I look at this in half the passage, going, cos of 0. Oh man, right? So that's a major problem. Okay, if you don't know it now, that's okay. It's the first day of the unit. Okay, right? But very soon this should not be an issue for you at all. Okay, cos of pi by 2 is going to equal what? I'll just grab it. Cos of pi is going to be negative 1. Cos of 3 pi by 2 is going to be here. Cos of 2 pi is going to be here. It's a periodic function. It makes a beautiful pattern. This does. Let's see. Okay, this is periodic, meaning that it goes on together. Now, as you're looking at this, what you should be thinking to yourself, you should be thinking, man, look at those first and second derivatives here, okay? When I look at this graph as I'm drawing, I'm thinking, wow, this is a negative first derivative with a negative second derivative. Hey, look, I have a negative first derivative with a positive second derivative. I have a positive first derivative with a positive second derivative. I have a positive first derivative with a negative second derivative. This is the way you should hopefully be thinking as a calculus student, okay? That's what I hope you're thinking. Okay? Okay, it should be. So this is y equals cos theta. If you weren't thinking that, that's okay. It just means you're a human being. Don't worry about it, okay? All right, I do the same thing for sine. I don't mean to yell with you guys with this. Sine of 0 is what? Oh, baby. Sine of 0 is 0. Okay. And it is just a shift to the next graph. That's all it's going to be here. Now, again, as a good calculus student, you should be thinking first derivative positive, second derivative positive, and so on all the way through here. Okay, just for fun, I'm also going to do this is y equals cos theta. So sorry, y equals sine theta. Okay. The main difference between those graphs is the starting point. If you remember nothing else about sine and cos, remember that cos of 0 is equal to 1, sine of 0 is equal to 0. That will really help you out as far as graphs and anything else that you're going to do here. Is it starting to come back a little bit for some people? A little bit? Yes? Been doing this for 2 years, so hopefully it's will be. Okay, let's do domain. You can go get it. I give permission to get your pen. Let's do domain and range. What's the domain of this graph going to be? Anything. Yes. Okay. So the domain of both of these graphs, these do actually go on forever. If you wanted to right now, you could type in sine of 8.9 trillion, and it will actually give you an answer between -1 and 1. That leads us nicely into our range, okay, which is going to be -1 and 1. It's impossible to take sine inverse of 1.2. Okay, the reason for that is because if you think back to SOHCAHTOA, it's like opposite over hypotenuse. That would mean that the hypotenuse is smaller than the other side. It doesn't make sense. Okay, so that's the logic for it. Okay, is this slowly, Matt, does this look familiar at all to you? Okay, good. Should I do a transformation graph, or is that enough on graphing? I want to do some numbers. You want to do a transformation, or want to do algebra? Nobody wants to do transformations? Okay, you might need to in life, but we're going to spend a whole day on graphing. I'm going to show you the way transformations work, and I'll do it in 10 seconds. The first number, you're multiplying the y value, so it's going to stretch this out. Okay, the x value is the compression, so it's going to get squished or stretched. Okay, the b is going to be a horizontal translation, so a shift left or right, and d is going to be a shift up or down, just like any other graph that you've ever done in life. Do you guys do this in advanced functions, I hope? Yes? We took it last semester. Did anybody? So you did do the last year. You did transformations last semester? Okay. All right, solving trigonometric equations. Okay, now this, I'm going to slow down here, I'm too excited. This is hideously, horribly, definitely important, because the way every single calculus unit goes, if you haven't figured it out yet, is the first part will be like sort of the derivatives, right? So all the derivative stuff. The second part will be a graph, so I'll try to graph this, and then we'll do word problems at the end, okay? So word problems will involve solving equations, okay? And when I taught this my first year, I thought, yeah, no problem. All these kids are pros at trig, no problem. And I got them to solve an equation like this. And the whole class just looked at me as if I wrote something strange on the board, okay? That might be the case right now, it might not be, okay? But this, something like this, you have to know. Did you guys do this last semester?
No, that's an example I gave.
Yes, this is an example I was going to do. Well, you have seen this before then, right? Yeah. Okay, something like this you do need to know how to do, okay? Now, so let's do this, let's pretend it's like a real, fundamental question here. Let's pretend that was like 4 plus 3x plus 4 equals 3x plus 2. What would our first step be? Right? I think we'll do 2 over instead of 4. Right? Because if it was like a quadratic, you'd want to do that, right? But if it was just like a linear equation, 4 equals 3x plus 2, right, it would move this over. So I'm going to call that 2 equals 3 cos 2 theta minus 5 or 6.
Why is there a dot second?
Because I okay, can someone be brave now? Are you guys passing notes in calculus class? What? Okay, 2 equals 3 cos 2 theta minus pi by 2. Okay, what's the next step? Divide by 3. So 2/3. Should have made this something nice and work for a special triangle. That's okay though right now. All right, now how do I solve, what's the next step here? Now, the way we talk about trig, you peel off one layer at a time. Did I ever tell this joke? That your math teacher is like an ogre. He has many layers. Get it? Yes? So the idea is that you're going to use one layer at a time. You ever see Shrek? Anybody? Anyway. Okay, what's the next step to that to get rid of here? What's the next furthest thing away from theta? What's the next thing we get away from? Yeah, go ahead.
You should make it like the cos 2a thing where you like.
Oh, you could do that. I'm not going to though, because that's going to. Oh boy.
What you would do in advanced functions.
Do you want to do the cos 2 thing?
It would take forever.
No, I'm not going to do that. You could do that though. It actually would probably work nicer because the pi over 2 would work a bit nicer. But I'm not going to do that. I do cos inverse right now. Hey, can someone change their calculator to radians? When I say someone, I mean everyone. Mel, since you were giggling at me before, you did cos inverse of 2/3 in radians. Can someone confirm that?
Yeah.
Of course, it's not 0.84, it's 0.84 like that, right? When it goes on forever. Okay, now this is where cast comes in. Okay? Why am I talking in my angry voice? I don't even know happy voice. Where's Michael when I do today? This is where cast comes in. As soon as you do sine inverse or cos or anything like that, this is where cast comes in here. How does cast work now for this, for cosine? What's my second angle going to be? Okay, good. So that means what then?
2 pi minus.
2 pi minus, okay? So I'm going to say, I'll do this on 2 boards. So I'm going to say that 0.84 and this was from cast. Okay, so as soon as you do sine inverse, cos inverse, or tan inverse, that's where you do the cast. All right? What's that, sorry? No, because the problem is that's going to affect your period then, right? Because when you divide by, okay, because think of what, I didn't actually get a chance to do transformations today, but with the 2 in for cosine, it's going to make your period instead of being 2 pi, your period is now pi, right? So if you do, instead of doing 2 pi minus, it's really going to be pi minus then when you're dividing by 2, right? Because everything is shrunk down by a factor of 2. Okay, so it messes up. So that's why I prefer to do it this step. You guys are calculators. If you want to do it right at the beginning, go ahead. Is this coming back to anybody here? Or am I talking to myself? Is this coming back to you? Yes? Okay. So now I'm going to divide by 2, and I'm going to say 0.42 equals theta minus pi by 2. Or, oh boy, I can't do this in my head. Can somebody give me this number? Can I do this, please? Can we do this number? 114. I can't do that in my head. That turns into 2.725-ish. Is that looking right to anybody here? This is good, I think. So we confirm you guys all have calculators except for me. I think that's right. Well, I'm so glad that you checked my answers. No one else in the class does. It leaves me great joy.
Well, the rounding should be 5.44.
Huh. I can't remember said that. How does it 4 5? I just know that's a lot better than that. Okay, good. Okay, great. Can somebody add pi by 2 to that? That's 1.57-ish. what is that then, 1.99?
1.9. Yeah.
4.29, is that right? Someone confirm that for me? That's right? Yeah, good. Okay, so those are unfortunately not our whole answers. Okay. Nate remembers this from last year. When Nate was in my class, I decided to pick on the football team. There's a football question on here, and I made so there were 10 answers in this question. So I did the question with something like 5 solutions, like it's periodic, so we got to keep on adding. The reason for this is what's happening is I'm looking for when the answer is 2/3. So here's my graph. We found this answer and this answer. My graph goes to here though. Okay. So the point is we're going to use this answer to get to here, and we're going to use this answer to get back to here. Okay, so that's the logical reason. We're looking for all the answers that are between 0 and 2 pi. All right. So how do we get the next coterminal angle? How do you get the next angle?
Something was signed.
Add pi. How'd you get pi? Yeah, right. We find out here somewhere along the way that our period equals pi. So remember we said our period equals 2 pi by k, which equals 2 pi divided by 2, which equals pi. So I'm going to say plus pi. I wish this was a beautiful special triangle. 1.99 plus pi, I can do that in my head, that's 5.13. So this angle is good and that angle is good. If I add pi to this, I'm going to be too big. Or 3. Somebody tell me why that answer is too big. Yeah, it's got to be between 0 and 2 pi. So how do I make that 4.29 or something that I like? Somebody help me here? Yeah, you can minus pi, right? You can add or subtract for this. So instead what I'm going to do is I'm going to do minus pi. I'm going to get 1.15-ish. Please note these are horribly rounded, okay? I just want to get the idea of adding pi and subtracting pi. Now the reason it's pi is because the period is 2 pi divided by k. Because the question originally said 3 cos 2 theta, that everything is divided by 2, all your answers there. Okay? Now this is deep stuff. We've covered a lot today. Like we covered all the advanced functions, a whole unit in one day. What did I miss from advanced functions? Did I miss anything? Identities. Identities. I'm not doing identities. Okay. You'll have the worst in identities coming up. Okay, so I'm just going to identities plus identities 2.0. All right, so I'm going to throw your homework on the board. The homework tonight is just practice on this sort of solving equation stuff to make sure that when I give you something like this, you don't look at it and say, oh no. Or if I say to you, Amy, what is sine 0? You can instantly tell me what sine 0 is. Good, okay, lovely, okay, right? But if you've been relying on Mr. Kemp or Mr. Lacey's unit circle, please recycle that, okay, right? Because you should be comfortable with it. If I say to you what sine of, actually maybe to end the class, I know we got a lot of time off, but I'm not going to be convened today. I'll write your homework on the board, and I'm going to write sine of 7 pi by 6. I'm going to show how we find that.
Mr. Sadler, close question. Mr. Van Strack did not give us.
He didn't?
Wait to fill it
Okay, just so that for the people that are smart talking to me here now. Let's say I were to ask you to tell me what sine of 7 pi by 6. When I say me, I don't mean me today, I mean me being your first year calculus teacher. Okay, and they were to ask that, okay? Because if you're taking calculus at First University, which I'd expect that most of you are, by the way, I tell the guys in the back, 4th page, there's no 4th page, Joe. 4th page is gone, I told you that, right? So they will expect to be able to do this without a calculator, okay? So don't use that. So if you need to sketch on the unit circle, go ahead. What's our identity dealing with sine? Tell me some identities that I could use for this. Well, I know one.
Signing could be.
Yeah, there's lots of them. I was gonna use this one though. Is that right? I'm gonna say. Is that gonna work for me? That's not gonna work. Okay, so 2 sign of A plus B. Is there another one? No, I want to get out and do this quickly. So this is gonna be, what's the next way to do this then? 5 plus 5 or 6? Is that a nice thing to do? Is that a nice thing to do? Okay, what's the identity for sign of A plus B? Somebody be brave. Okay, now here's the things you have to know. What is sine of pi going to be? 0. And what is sine of pi by 6 we can probably do, but we won't do that right now. What is cos of pi going to be? 1. So this equals negative sine of pi by 6, which is negative 1/2. Now there is an identity, I'm sure, that there's an identity you can use directly from that. I'm doing the long way to do it. Okay, right, but you can get identities for all these things too. Sorry? Well, let's go to cast. Let's just start with cast to begin with here, though, okay? Sine is going to be your y values, right? Okay, so set 7 pi by 6 is over here someplace. Okay, so again, positive, positive, negative, negative. Okay, so I'm just saying a little bit. Okay. So something like this, if you're ever asked to do this, you should be comfortable doing something like this. Okay, right? And it shouldn't be like the hardest thing in the world. I'm sorry I'm so mean, I don't mean to be. Okay? But I just am. I'm a teacher. Okay, 212, 2, 6, and 7, 2, 17, 1, and 4. That's your offer tonight. Anything else about trig you want to ask? Oh, goodness.